Okay, thank you for joining us. Yeah, so the first question over here, okay, I'll just go through all these answers with you guys. Okay, define Hess's law. Okay, so please remember, Hess's law is always defined as the total energy change. Okay, total energy change is independent. Okay, is independent of the reaction is independent of the reaction. Okay, so this one, okay, this is going to be the definition. Now, for question number two, okay, they are here they are asking us draw enthalpy cycle, okay, to calculate the enthalpy change of reaction for the following reaction. So if you want to draw this, okay, so first, okay, we have to write down, okay, 2Al, okay, plus Fe2O3, okay, and just write down the equation. So 2Fe Al2O3. Of course, you need to write the states and so on, okay, but for this, I'm just keeping the states over here. Now, this is going to be your enthalpy change of reaction. Yeah? So you want to draw an enthalpy cycle. So when you are drawing the enthalpy cycle, okay, normally if you want to do this, okay, we always refer to the next things. Yeah, so you can have a look at B. They have already mentioned something to do with formation. So this is actually a hint for you to select how am I going to get this particular reaction, or how am I going to draw this enthalpy cycle. So what I will suggest to do, okay, so the easiest way, okay, you put it, okay, in the box, and okay, you put this in a box, okay, so that we can see that this is going to be the reactant and the right is going to be the product. And okay, because it's formation, please use this arrow to form. Yeah. So you do remember that aluminium, okay, aluminium, you do not need to form them. Yeah, aluminium is element, so we do not need to form them. Okay, in order to form Fe2O3, you need to form them from their elements. Okay, so therefore, okay, we need to have, okay, Fe2 means you need two Fe, okay, the element, and then oxygen, okay, you need three oxygen over there, so you need to form them, okay, using the 3/2O2. Okay, that's actually the formation for Fe2O3. Okay, but okay, we still no need to close the bracket or the close the box. Yeah. So this is the formation, okay, for the Fe2O3. For Al, you no need to form. Yeah, no need to form. Okay, now let's look at this part over here. Let's say we try to connect. So in order to form, okay, the product, okay, so which is going to be Fe, okay, you no need to form Fe, yeah, because it's element. But what you notice over there, okay, there is two Fe, they will give you two Fe. Yeah, I'm not going to add anything over there. This is the two Fe is from the reactant, yeah, from the reactant, and then as a product, they stay as a product to Fe. Now, what is important over here is to form Al2O3. Okay, to form Al2O3, the elements are going to be 2Al. Okay, and of course, you want to actually form O3, so you need to use the element O2. So you want three atoms, so 3/2. Okay, you have this. Now, what you need to do next is, okay, this is very important. Okay, for this 3/2O2 and then 3/2O2, okay, normally what I do is, okay, rather than putting them here, okay, we can just simply put them over here, 3/2O2 here, okay, and then you can also put 3/2O2 here, whereby, okay, you can cancel this. Okay, and you can also cancel here, and you can simply have another box, and you put it like this. Okay. So if I want to, this is already a HESS'S cycle, yeah. So if you look at it, okay, this one's supposed to be, if I put it properly, 2Fe, 2Fe, you plus the 2 aluminium. Okay, bring it closer. Okay, and this is going to be, okay, this value is enthalpy of formation of what? Enthalpy of formation of Fe2O3. Yeah, so I'll write down Fe2O3. And this is going to be enthalpy of formation of, okay, Al2O3. Okay, so all the HESS'S law will apply over here. Okay, this is going to be if you want to calculate the enthalpy change of reaction using the following information. Yeah, so I told you in HESS'S law we have total of three methods to calculate. Okay, three methods to calculate. And this is the first method. I think the first method is going to be by drawing the enthalpy cycle. Then, okay, you try to use the enthalpy Hess's law to solve this. So this one is actually similar with the second method, which is going to be clockwise equals to anti-clockwise. Yeah. So you can see that, okay, the here, okay, the one in red color, okay, this is going to be clockwise. Okay, clockwise. Okay, so this is going to be enthalpy change of formation of Fe2O3. Okay, is going to be added with the enthalpy change of the reaction. Enthalpy change of the reaction equals to enthalpy change of formation of Al2O3. If you cannot see, yeah. So here, okay, you can see if I want to put them in, okay, so you just need to use the value, okay, negative 824.2. You add with delta HR equals to enthalpy of formation of aluminum oxide is negative 1675.7. So this is going to be enthalpy change of reaction is going to be negative 1675.7. You plus with 824.2. Okay, I need your help to help me to calculate this, yeah, so that it will be easier. Okay, once you have calculated, please let me know. Just say the answer, no need to type. So anyways, okay, this is still the method number one. Okay, I will just write down. This is the normal method, the conventional method. Okay, not all the time they will ask you to draw the enthalpy cycle. Yeah, but if they ask you to draw, just use it. Yeah. So this one is the method number one. Okay, of course, the method number two that I taught you is the modified version of the method, which is, okay, I put a circle there, okay, and then, okay, I curve this, okay, curve this according to it. Okay, so see, same, okay, clockwise equals to anti-clockwise. Okay, that is going to be eventually you will get the same thing. So I'll just put method one and method two. Okay, the method two normally, okay, I refer it as Mr. Gopi's method or whatever method that you want. Yeah, you can actually name it. Okay, but eventually you will end up with the same answer. So Bielson, can you help me with the calculation? What's the answer?
Negative 851.5.
801.5, yeah, kilojoule per mole. Okay, thanks. So that is going to be the first question. Yeah, second question. So let's actually move on to question number three. Okay, so this one is going to be we can use, okay, calculate. Yeah, they say calculate the standard enthalpy change of formation. So in order to form, okay, C2A6, you need to write the equation. Yeah. So carbon, the element, so must be 5, and then the element for hydrogen is going to be 8. So the H2 must be in gas. So you try to actually make it 2. So I just put 2 and then put 3. So this is the enthalpy change of formation. So I'll just put enthalpy of formation, or I can also put it enthalpy of formation, which I do not know. Yeah, which I do not know. The relevant enthalpy change of combustion are given. Yeah, in this case, I think when I print you, okay, I have already given the enthalpy of combustion of hydrogen. Okay, enthalpy combustion of hydrogen, missing information. Yeah, negative 85.8, and enthalpy change combustion of carbon, which is 5, is going to be negative 559.7. So this one we've already covered in the class, yeah. So I'll just go a bit faster over here. So first, okay, you write down enthalpy change of combustion of carbon dioxide. So I write down carbon plus oxygen to give you carbon dioxide. Okay, that is going to be given delta H is going to be negative 395. Okay, sorry, 393.5. And then, okay, the enthalpy change of combustion of H2. So you put H2, okay, burn with oxygen, they will give you water. Okay, so basically combustion means 1 mole of 1 mole of hydrogen is burning. Yeah. So make sure that okay, you do not change this value. This one just okay. So the delta H is going to be negative, okay, 285.8. Okay. Then, okay, we also have enthalpy change of combustion of carbon. So carbon plus oxygen. I think, sorry, my mistake. This one is not enthalpy change of carbon. Okay, that's going to be enthalpy of combustion of C2E6. C2E6. So we write down the combustion for C2A6, okay, plus oxygen. Okay, alkene and alkene, yeah, hydrocarbons, they will always give you carbon dioxide and water. So we just try to balance this out. We still want more over there because combustion means you are combusting or reacting 1 mole of the substance with excess oxygen. Yeah. So there's 2 over here. Hydrogen, okay, you 6, so I put 3 over there. Now, when I calculate the number of oxygen atom, I have 7 total. So 7 over. And so this is the value. Okay. The idea is to write the equation. Yeah. So this is going to be negative 1559, okay, 0.7. Now, so the idea over here is you are going to use okay, all the information that you have over here so that okay, you can get this particular equation. So the best method is, in this case, previously I showed you method number 1 and method number 2. So this is going to be method number 3. So method number 3 is very suitable whenever we are having rearranging or when we normally have combustion, we have to rearrange okay, the equation. So how to rearrange is quite simple. It's like puzzle, yeah. So first of all, you look at okay here C2A6. So you look at these 3 equations. See where is C2A6? This is C2A6, and it's 1 mole. So 1 mole is okay. But another problem is this is the product, and this is at the reactor. So what you need to do, you need to rearrange them into 3H2O plus 2CO2 to give you C2H6 plus 7 over 2O2. But now because we rearrange, okay, because the reason why we rearrange, we want it to come to the right hand side. So we are going to have plus 1559.7. Okay, that is done. C2H6. And have a look at the reactor, which is 2 carbon. Look for the carbon here. So there is only 1 carbon here. Okay, just have a look at other equation whether you have carbon or not. So there's only 1 equation with the carbon. So I am going to select this carbon. Yes, carbon now, okay, is on the left. Okay, no need to change the position. But there's 2 over there. So what you need to do, you need to times everything by 2. 2 carbon plus 2 oxygen to give me 2 CO2. And now the delta H is going to be, you need to times this by 2, which is going to be negative 393.5 times by 2. Okay. So once you have that, okay, this is going to be okay, already settled okay, for carbon. So next is to look at the hydrogen. So look for the hydrogen, from the equation again, and I found out the hydrogen is here, but I need three. So I no need to change the position, but still need to times by three. So 3H2 plus 3 over 2O2 to give me 3H2O, which is now my delta H is going to be 3 times negative 285.8. Okay, so you have this, yeah. So it's slightly laggy when it comes on the screen sharing, okay, but eventually, okay, it will be there. So once you have that, okay, once we have, okay, okay, hold on, yeah, so it's reconnecting. Okay, now once you have the equation over there, okay, so it is going to be 3 times 285.8. So we know that, okay, if you just want to find the enthalpy change of formation over here, which is going to correspond to this equation, you just need to add all this. Yeah, the one that you have done, you just need to add. So the delta HF is going to be 1559.7 plus 2 times negative 393.5 plus, okay, 3 times negative 285.8. Yeah. So that will give you a value. Okay. So this value is the answer actually. Okay. But if you are wondering, yeah, why suddenly we do this? Yeah. Of course, okay, if you still have a question like why we do this, basically once we rearrange three, because eventually when you add all these three equations, it will give you this equation, and I can prove it to you also. Okay, so this is can be easily proven, yeah. But in exam, you do not need to prove that, so no need to worry about that in exam. Okay, that I can show you, but I still want someone to help me to calculate, yeah, over here. So what is going to be the answer for this? Maybe Aurelia, what is the answer, Aurelia? You guys, all of you are muted, so maybe whoever have the answer, please just give me the answer, yeah. Even Bielson, if you want to give again, also can, yeah. Okay, while you guys give me the answer, I will show you how to show the equation. Okay, you can see that when you add these two equations, this one and this one will cancel. This and this will cancel. Okay, and I will get 2 carbon plus 2 oxygen and 4O2 oxygen plus 3H2 plus 3 over 2 oxygen to give me.
Negative 84.7, yes, sir.
I don't have the answer now, yes, but if it is calculated, then that's going to be negative 84.7. The others can check, yeah, yes, the answer, yeah. So this one, okay, once you have this, okay, so I'll just put it here. Then, okay, they will give you C2H6 plus 7 over 2O2. So 4 over 2 plus 3 over 2 is 7 over 2 O2. So this one and this one can be cancelled. So you get 2 carbon plus 3 hydrogen to give me C2H6. So you don't need to worry whether they are going to give you the all the time. Okay, once you rearrange it properly, you are going to get the same equation. Yeah, so you just need to rearrange and straight away calculate. And that is very important. Okay, but of course you need to be careful. Yeah. Bielson, are you getting the same answer as well?
Yes.
Okay, so we will move on. Yeah? So now let's look at this number 4. Okay, draw an enthalpy cycle to calculate the enthalpy change of formation of ethanol. So first, they say that formation of ethanol. So first, you write down ethanol C2H5OH. And this is ethanol. Okay, those who do not know, you just read out here, C2H5OH. But one mole formation here, one mole is being formed from carbon, okay, and hydrogen. In this case, there's oxygen. So carbon must be in graphite form, the stable form. So here, okay, you just need to write down this is 2, and my hydrogen has 6 over there on my right hand side. So I just put 3. oxygen is going to be oxygen is going to be okay, oxygen is going to be only one, so I'll just put half over there. Yeah. So this is going to be basically enthalpy change of formation of C2H5OH. Yeah. Hold on, yeah. I'll just Pugan, I have plus. Okay. I have plus. Okay, so once you have this, okay, so they are asking us to use the combustion data here. So do remember the best way to solve this is by using rearranging of the equation. Okay? In this case, okay, they are asking us to draw an enthalpy cycle to calculate the enthalpy of formation using the change of combustion. So it means now they are asking us to use method number one. Okay, method number one, which is going to be we have to draw this cycle. So this one may be difficult, okay, but again, if let's say there is question in terms of let's say MCQ or paper two, okay, they didn't say you have to draw enthalpy cycle. You can just straight away, okay, use method number three, which is going to be rearranging like what we have done earlier. Yeah. But in this case, again, okay, let's see. Enthalpy change of formation is C plus O2 to give you carbon dioxide. This is going to be H2 plus O2 to give you H2O. So this will be combustion of this will be C2H5OH plus O2 to give you carbon dioxide plus water. Okay, so 2 and then hydrogen 3. So you have oxygen total 7. So this one. Now, we are going to use all these three information. We are going to try to put them into a cycle. Yeah. So how to do that? So first of all, okay, you can see here. Okay, let's actually start from the back because here got many things. So if I start from the right, so let's say I told you earlier, you put a box. Okay, you put a box. And then, okay, it is reacting, yeah, not forming. Okay, so when they are reacting, okay, so C2H5OH is reacting with what? Reacting with O2. So I put the O2 here. So plus 3 O2. Okay. And they are going to give me 2 carbon dioxide. Okay. Plus 3 H2. Okay, write down first. Okay. And then, okay, let's have a look at this side now. Okay, this one you have to do one by one first, yeah. So here you see carbon. Okay, later we can erase and do again. So you see carbon, but 2 carbon. Okay, so if it is going to be 2 carbon, this is going to be you need to times everything by 2. So this is going to be enthalpy change of 2 enthalpy change combustion of carbon. Okay, 2 times enthalpy combustion of carbon. And you are going to get, okay, when you times, you will get 2 carbon dioxide, which is 2 carbon dioxide. Okay, so that one is settled. Now, let's look at hydrogen. Hydrogen, there's 3, yeah? So I put 3. So react with 3, okay, and then to give you 3 moles of water. So this is also settled. So this one, 3 times enthalpy combustion of hydrogen. Okay. For the oxygen, okay, oxygen cannot combust with oxygen. Do remember that. So in this case, when I add these two, okay, you can see that the number of oxygen that are involved over here is going to be 4 over 2 O2 and then 3 over 2 O2, which is going to be 7 over 2 O2. Okay. But from that 7 over 2 O2, okay, please remember half stay put. Okay, half was already done. Okay, half O2 is already there. So the remaining should be also plus, okay, total plus 3, okay, which is going to be 7/2 minus half O2. Okay, that's going to be 6/2 O2, which is going to be 3/2. I hope you can understand this. Yeah? So now, if I erase this part, okay, and try to make it as one arrow, yeah. So erase this, okay, erase this, and I put one main arrow over here to form this. Okay, and okay, you can see that okay, I can bring the O2, 3/2 here. Okay, and then let's say rewrite this properly, bring it a little bit down, and then bring this over here. And then now you put the table, everything will be balanced. How? 3/2, 3/2 here, 3/2 over here is all balanced left and right. Okay. And then you are going to have, okay, you are going to have the HF, okay, and so on. So now, okay, if I want to, this one, the enthalpy cycle is already completed. Okay, now I want to calculate the enthalpy change of formation. So this is still method number one. Okay, so clockwise equals to anti-clockwise. So this one is going to be enthalpy change of formation. Okay, plus, okay, this one is going to be enthalpy change of combustion of C2H5OH, which is going to be, if you want to write first also can, C2H5OH equals to, okay, uh, 2 times enthalpy change of combustion of carbon plus 3 times enthalpy change of combustion of hydrogen plus no, 3/2 nothing, yeah, so no plus. So you just need to put in the information, okay, this one we want to calculate. Enthalpy combustion of the ethanol is negative 1367.3. Okay, please calculate for me as I keep on writing. 2 times, okay, for carbon, negative 393.5. And then for hydrogen, 3 times, negative 285.8. And basically, we are looking for enthalpy change of formation. 2 times. Need to rewrite again. Okay, you help me to calculate. Then this one go there is going to be plus 1367.3. Okay, what is the kilojoule per mole? Okay, help me to calculate, and that will be your answer. Okay, answer key I have already shared to you already. Yeah, so please take note of the answer key. Okay. Number 4. Okay, if I look at the answer key, I have the value. Yeah, but I just want to check with you guys. Okay, so okay, we have so many of you guys over here. So can someone give me the answer?
Negative 277.1.
Negative 277.1. Yes. Okay. So please take note. I think there is. Yeah, I think the answer key that shared. I think the students working in the group. Yeah, the one that I shared, the one with the black background. the students made a mistake, yeah, in their calculation. I think they use value. Okay, okay, I'm wrong over there. Calculation. So, anyways, this is the correct one. Okay, please take note of that. Okay, later after we finish this, I will share this also with you guys. Yeah, so make sure you check. So can I have another person to confirm this is the answer? Just follow my working over here and then you will get the answer.
Yes, sir. I also got the same
Okay.
one.
Okay, so this is the answer. Please take note. Yeah. So the answer key that I shared again in the WhatsApp group. Yeah, that is actually done by students. That part is wrong. Yeah. Please take note. Now I will move on. Okay. So you see, this is also going to be still first method. Yeah. So of course, I taught you, okay, for this question, the best method is to use this method, yeah, rearranging equation. And that is going to be the best method. But if you ask me what is the best method, then you still use this method because they asked me to use it, yeah. So because they asked me to draw the enthalpy cycle, so I need to use this method, which is method 1. So please take note of that. So now in exam paper, okay, they are ask you or force you. Yeah, sometimes in paper two, sometimes they do force you. Yeah. But doesn't matter what method that you use, if you can get the answer, then it's good. So you see here, okay, question number 5, the standard enthalpy change of combustion and ethanol is given. And then they say glucose can be converted into ethanol. So they want what is the enthalpy change of this? Yeah, enthalpy change of reaction for this case. Yeah. So what is given for us is combustion. And we told you, okay, whenever we are dealing with combustion, unless we are dealing with formation, then you use Mr. GOPI'S method. Yeah? But if it is going to be combustion, the best way is to rearrange the equation. And I will show you how to actually use the rearranging equation in a fast way. Yeah. So you see combustion of glucose and ethanol. So this is going to be glucose. Yeah? Glucose, and this is going to be the ethanol. So combustion, yeah. So C6, write down the equation. C6H12O6 plus with oxygen supposed to give you carbon dioxide and water. Write down that first. And then the combustion of C2H5OH, okay, plus oxygen to give me carbon dioxide and water as well. So first is to balance the equation. So this is combustion, so you cannot disturb the value in front. Yeah. So 6 carbon, you put 6. Hydrogen 12, I put 6 over there. How many oxygen? I have 12 and then 18. So I have 6 over here. So I must have another 12. So I put 6. And this value is given, okay, which is going to be the enthalpy combustion of glucose is negative 2820. And then now, okay, let's do the balancing same for the ethanol. Okay, so you have 2 over there. And then the hydrogen, I have 6, so I need to put 3 over there. And how many oxygen on my right hand side? So I have 3 oxygen plus 2 times 2, 4, so 7. 1 here, so I need to put 3 over there. So it's balanced. So I put the enthalpy change is going to be given also negative 1368. Yeah. Now, the next is playing around, okay, with your like something like your jigsaw puzzle, yeah, playing around. So here, okay, if you put it over here, okay, have a look at the equation. This is on my left, okay, so you check. Okay, this is on my left, so no problem. I no need to change anything. I just leave it as it is. Yeah, leave it as it is. Number also no need to change. But okay, let's have a look at here. Okay, I'm not going to look at carbon dioxide because carbon dioxide is existing in both equation. I don't want to get confused. Okay, but I will look at this. Yeah, ethanol. Ethanol. Okay, if I look over here, ethanol is here. But the problem is, okay, I need the ethanol to be on my right hand side. Okay, so first of all, okay, I will still use this equation. See this. Okay, I put it here. I still need to use this. Okay. But when it comes to ethanol, I need to bring it to the other side and times by 2. Okay. So first, let me bring it to the other side first. So 2CO2 plus 2 C2H5, sorry. I just need to use this one. 2CO2 plus 3H2O to give me C2H5OH plus 3O2. Okay, which one? This delta H now will become plus 1368. Okay, but do remember I want two moles here. So now everything must times by two. Okay, so I'll just use the red pen over here times two, so it becomes 4 times 2, it will become 6. Okay, times 2 will be 2 times 2, this will become 6. This must be times 2 also. Yeah. So now you don't need to worry about anything, you just need to, okay, just need to add these two. This will give you the enthalpy change of reaction, which is going to be negative 2820. You plus with 2 times 1368, you will get the answer. But if you still have doubts, okay, how come this one will give me this? Yeah, I already told you, you can always cancel, 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 and cancel. Okay, and you will be able to see that, okay, this one, okay, you already have that. You can have this, okay, and then you see 4CO2 on my left, okay, 4CO2. On my right, there is going to be 6CO2, like maths. You bring it over here, 6 minus 4, you will get 2 CO2. Okay, so it's balanced. So what is the answer over here? Can someone help me to calculate? Number 5. Okay, you can see I have negative 84. So the answer is negative. Okay, so the answer is negative 84. Okay, Wilson, is that okay?
Yeah.
Okay. So the answer is negative 84. Okay, this is again, okay, method number 3, rearranging, okay, the equation, the best method, yeah, the best method, rearranging. Okay, this one, okay, is going to be, you see, enthalpy change that are difficult to measure directly can be used can often be determined using HESS'S law to construct an enthalpy cycle. So you have an enthalpy cycle over there. Which enthalpy change is indicated by X? It looks very much difficult, okay, but if you look over there closely, okay, you can see, okay, this enthalpy change formation is going to form what? They are going to form this. Of course, they cannot form oxygen. Why you want to form oxygen? Because it's already formed. Enthalpy change and formation of elements are going to be 0. So if they are forming over here, so of course the carbon, yeah, carbon is going to be the element, hydrogen, they are going to be the element, and so on. So of course the two O2 that. So what is this enthalpy change of formation over here? So this is going to be the enthalpy change of formation of methane or something like that. Okay, and here you can see the same. Okay, this is going to be enthalpy change of formation of carbon dioxide, and here is going to be enthalpy change of formation of water. And you don't ask me, oh, water is readily formed by God, sir. Yeah, liquid. No, water is not element. Yeah, please remember. Okay, H2O, they are not element. So they are formed from hydrogen and oxygen. Yeah. So you have all this. So now they are asking us to calculate what is X. So this one, okay, the best method to look at it is just make sure you use the HESS'S law cycle. Yeah. So you can see here, if you have, okay, if you have the X, okay, X is going to be and which enthalpy change is indicated by X. So although this one X is supposed to be, they didn't find what is the delta H or something. This is 2 actually it's supposed to be 2 times enthalpy change of formation of water. Yeah, but again, they just want X, so we just leave it as X. Okay. So here, this is enthalpy change of formation. So 1 mole is okay, 1 mole is okay, combustion is okay. So first of all, okay, you put them into this cycle. Okay. So clockwise equals to anti-clockwise. So you will have delta HF of what? HF of CH4. Okay. And then plus delta H of combustion of what? CH4. Okay. This one done, this one done must be equal to enthalpy change of formation, formation of carbon dioxide plus, doesn't matter, they give this as X, so it is still plus X. Okay, so you want X, okay, X is going to be this value plus this value minus this value. Okay, supposed to be like that. But in this case, okay, they ask you what is X only. Yeah, so they don't want you to find the relationship of this. So what is X only? I think this is more easier. Overthink about this question. So what is X? Okay, X is 2 times enthalpy change of formation of water. Okay, 2 times of enthalpy change of formation of water, and it's not going to be negative because you're forming water. The arrow is showing towards water. So if you look over here, this is for wrong. Okay, 2 times enthalpy change. So this is a very easy question actually. Okay, I was thinking they are asking for relationship. Yeah, so the answer is going to be D. Okay, let's see who are still here. Yeah, Mayumi, can you understand this explanation, Mayumi?
Yes, sir.
Okay, so let's move on. Yeah. So here, okay, you have ethanol is increasingly being used as fuel for cars. Yeah. So you have formation, and then they are asking us the enthalpy change of combustion of ethanol. Okay, I will write down the equation first. You tell me which method we should be using to get easy mark or to solve this easily. Yeah. So first of all, to find the enthalpy of combustion of ethanol. So ethanol is C2H5OH. You combust, you get this carbon dioxide plus water. Okay, so of course these two. So hydrogen I put 3. Okay, and then oxygen 7. So 7 1 there, so 3. Okay, I want to find enthalpy of combustion. This value. Yeah, I want to find this value. So now, let me ask. Oh yeah, so maybe Aurelia. Which method do you think should we use? Method number 1 is the conventional method. Method number 2, Mr. Gopi's method. Method number 3, rearranging the equation. So which one should we use?
Uh,
Which one do you think will be easier to
the one that
do? Remember the formation, yeah? And then there is if rearranging, you need to write all the equation in, and then you rearrange. Okay?
no,
And you still can actually find the answer using rearranging. Okay, but which method that you are going to use? Mr. Gopi's method, right? The one that the arrow, yeah. So Aurelia, you have another method on your own.
yeah.
Yeah, you have your own method, you carry on. But do remember, at the end, okay, it must still reflect HESS'S law. Yeah. So here, okay, I will use my method over here because formation, yeah. Formation to form, to form, to form, to form. Okay. And oxygen, you no need to form this element, which is going to be 0. Okay. C2H5OH, you see C2H5OH formation is given, so negative 277. And then carbon dioxide negative 393, negative 393. I have 2 moles, so 2 times negative 393. For water, negative 286, but I want 3 moles, I must times by 3. And now, okay, I use that, okay, which is going to draw a circle over there. Going to change everything slightly. uh, follow the circle. Okay. So I know that clockwise equals to anti-clockwise. Okay, so I just need to put negative 277 plus 0 plus, this is clockwise also. Okay, copy change of combustion equals to 2 times negative 393. Okay, plus 3 times negative 286. Okay, and you find the enthalpy change of combustion. Okay, Mayumi and maybe Wilson and Aurelia, please help me to calculate with this. Yeah. So this one, I bring it over there, plus 277.
Negative 1367.
Okay, so negative 1367. So this will be, okay, whatever method that you use, yeah, okay, even you might have method number 4, method number 5, okay, in the end, okay, it still must reflect the HESS'S law, yeah, as long you get the answer, fine, yeah. Don't use your own method, but in the end, get the wrong answer. Yeah, so that is important. Okay. Now let's move on. Okay, this is going to be another another question, but this is like you see, yeah, the way that they write is same. Yeah, but now you tell me which method is the best. Yeah, so maybe I will not ask Aurelia, I will ask Wilson or maybe Mayumi. So here you see propanon. So enthalpy change of propanon, yeah, formation. So propanon is going to be C3H6O. So to form, so it must be formed from 3 carbon. Okay, I'm not going to write graphite over there. So hydrogen and oxygen. So hydrogen, I put the 3 over there. And then oxygen, I put half over there. This is enthalpy change of formation. And then they have given the combustion. Yeah, combustion. So this one, of course, combustion means hydrogen. Yeah, so I write down hydrogen plus oxygen to give you water. So of course, this is going to be half. And then combustion of carbon, okay, this is going to be carbon dioxide, combustion of propanon, C3H6O plus O2. Okay, they are going to give you carbon dioxide plus water. So 3, okay, hydrogen 3, so oxygen 3. Okay, so all these equation using this, okay, I need to solve this. So which method do we use? Of course, I suggest method number 1, the conventional method. It's a bit difficult to draw the cycle and so on, but up to you if you want to use that. Method number 2 is GOPI'S method, the formation method. Method number 3 is rearranging. So Wilson, okay, which one do you think the method easiest to do this question? Rearranging or the one we did earlier?
The GOPI method is it?
Gopi method is this one. Okay, formation. Yeah, do remember. Okay, Mr. Gopi's method is only for formation, but in this case, the formation is over here. I'm not having the value for the formation of, like for example, formation of C3H6. I'm not having that value to form this, okay, we are not doing that. Yeah. So it means the data that is given for us is the of combustion. So in order to use this, okay, the best method is to use the rearranging method. Okay, it means you need to rearrange this. Okay, so that is the method. So please understand when to use this method. This method is being used whatever that you want to find, the equation that you want to find, but you have all the formations. Okay, that is going to be for GOPI'S method. But this one, okay, the best method is rearranging. Okay, which is, okay, you see here, I1C3H6O. This is on my left. Okay, so I need to make it to the right. So what I need to do, plus 3O to give me C3H6O plus 3O2. And now my delta H is going to be no longer negative because I rearranged. So it's going to be positive 1786. Okay. So this is done. And then I'm not going to focus on oxygen because both of the three of the equation has oxygen. So I'm not going to focus on this. My focus will be on the carbon. So you see the carbon, there is only one carbon here, but I want three. So no need to change the position, but just need to times everything by three. And the delta H is going to be 3 times, okay, negative 394. Okay, so this one is settled. Okay, for hydrogen, okay, so I need to times by 3. So 3 hydrogen plus 3 over 2 O2 to give me 3 H2O. So delta H is going to be 3 times negative 286. Okay. No need to worry about oxygen. Okay. In the end, okay, if you trust your method, if you trust everything you did, I feel that you have done it correctly. You add these three, okay, you will get the value of this. Okay. Delta HF is going to be 1786 plus 3 times negative 394 plus 3 times negative 286. You will get the value. Okay, help me to calculate. Aurelia, Mayumi, if you have calculated, tell me the answer, yeah?
Negative 254.
254, yeah? So negative 254. Okay, let's move on. Okay, Mayumi, can we move on? No response. Aurelia, can we move on?
Yes, sir, can.
Okay, so let's move on, yeah? Okay. Now, given the following enthalpy changes, what is the standard enthalpy change of formation? Yeah. So this one, yeah, maybe once you know what is happening and so on, you can apply this. So I'll just put this I2 in gases form, 3Cl2 gases, okay, 2ICl3, and this value is negative 214. Okay, and there is only one information given, yeah, one information given, which is going to be, I think, two information, this one and this one, yeah, but we want the enthalpy change of formation, okay, formation of iodine trichloride. So formation means to form this, okay, there are many methods that you can use, ICl3, to form this you must actually form them from their elements. Number two, okay, must be in solid form. Okay, the CO2 must be in gaseous form. Okay, and then three, okay, so this one is half, okay, and this is going to be 3O. Yeah, this is the one that they want you to find. Okay, they want you to find this. And they have given you the other equation. Okay. So they have given you plus 38. Okay, you need to select which is the best method, okay, to do this. Okay, and I'm here just to tell you what is the best method, yeah, to do this as well. Okay, so the best method to do this is going to be you can either use rearranging the equation, okay, and you can also use, okay, day one this, okay, ICL3, okay, so you can use the rearranging, you can use this, okay, you can put this I2 to become solid, okay, you can use this, okay. Let me show you both methods, yeah, I think better, okay. So if let's say I want to find this HF, okay, so ICL3, let's say I use the rearranging method first, yeah. Okay. So ICL3 solid, okay, is on my right. Okay. So here this is on the right, but it's for 2. So what I do, I divide everything by 2. So which is going to be half I2 gas, okay, plus 3/2 Cl2 gas to give me ICl3 solid, and now this delta H is going to be divided by half, yeah, so negative divided by 2, yeah, divided by 2, negative 107. Okay, so that is going to be my first equation, okay, which I have solved for this. Then, okay, I have the, okay, for both of these equations I have Cl2, so I'm just worried about, just think about I2 only. Yeah. So you see the I2 solid is going to be at my left. Yeah, at my left. So I just need to make this into half. Yeah, I just need to make this into so half O2 I2 to give me half I2 yes. Okay. And this is going to be delta H is going to be, if I have half, it's going to be 19. Okay, 19. So here, okay, once I have this, okay, I'm going to use these two. Okay, when I add, okay, hopefully I'm going to get this equation. Okay, so you can check also when I add this, okay, am I going to get that equation or not? Okay, so when I add, okay, what I can cancel, okay, I can cancel this part. I can cancel this part. And in the end, I am going to get half I2, which is going to be solid, plus 3/2 Cl2, which is in gas, to give you ICl3, which is going to be split. And delta H is going to be negative 107 plus 90, okay, which is going to be negative, and I think the answer will be negative 88. Okay. So this is going to be by using this method of rearranging, which is eventually it is going to give you this. Okay. So you choose. Yeah, if you choose want to use the rearranging method, you can still get the answer. But I will also show you the Mr. GOPI'S method also. Yeah. So my method also. So see which one is easier for you. Okay. Here. So now, okay, I have this particular equation, okay, and I want to find the enthalpy change of formation. Yeah. So what I do is, okay, I put the I2 gas just with the same equation that I have. So plus 3Cl2 gas. Okay, and I have this negative 214, 2ICl3 solid. Now, I know that to form this, okay, this is 2 times delta H of formation, which is I want to find the formation. Yeah. So because 2, yeah, I put that. To form Cl2 gas is 0. Do remember, as standard condition, F2, Cl2, Br2, and I2. Okay, this is gas, this is gas, this is liquid, this is solid. So therefore, okay, you see Cl2 is gas, you do not need to form that. So element is going to be 0. So here, okay, I2. I2 is also element. Is it 0? No. If it is I element in solid state, okay, then it's going to be 0. But this is in gaseous state. So you need to use this formula. Okay, from solid to become gas. This is to become gas. So it requires 38. So to form I2 gas, okay, from the solid is going to be 38. 38. So now you use that, which is going to be the circle there. Okay, and then you put this one over here, over here, over here. So it's going to be 38 plus 0 plus negative 214 clockwise equals to n times twice 2 times delta HF. So this one, okay, is going to be delta HF is going to be 38 minus 214 divided by 2. You will get the same answer as well. So Wilson, which method do you prefer?
The third one, rearrange.
Rearranging, yeah. So it's up to you, yeah. Which one do you prefer? Okay, but again, all the methods you can get the answer. Yeah, please remember that. Okay. So Aurelia, your method, okay, is totally different than this, yeah.
Yes, sir.
Yeah. So maybe one day you show me how you use that method also, yeah.
Similar to Mr. Gopi's method, but then different, but then similar.
Okay, it's okay. Then you show me during class time, yeah. I want to see you also. Yeah. So let's actually move on, okay, to question number 10. Okay. So enthalpy changes of combustion can be used to determine the enthalpy changes of formation. Yeah. The following equation represents the enthalpy change of formation of butane. So this is the formation of butane. Okay. Don't just stick to formation of Musagopi's method, not like that. Yeah. So by using the following enthalpy change of combustion, you see many combustion to find formation. Okay, what is the value of this? This is the best method that I will suggest is going to be rearranging. Yeah, combustion to find formation. But let's say every formation is given, you need to find something, then my method will be very useful. For in this case, the best method is rearranging. Yeah, so carbon plus oxygen, carbon dioxide, hydrogen plus oxygen to give you water. So this one will be half. Butane, so H10 plus oxygen, carbon dioxide plus water. So 4. Okay, this is 5. Yeah, 5. And then oxygen is going to be 5 plus 8. So 13. So 13 over 2. Yeah. So all these equations. So now I need to rearrange these equations so that I get this. Okay. But now by now you can see that I'm trying to limit the things that I write. Yeah. So once you're good and once you are comfortable with with the calculation, I'm very sure that you can actually make it simple. Yeah. So in this case, you want C4H10. Okay, C4H10 is over here. You want to make it to the right. So to the right, okay, it means that you need to change it to the right. So it means that the butane value, okay, I'm not going to write blah 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 3 equation. Okay, I'm not going to write that. I'm going to simplify that. Okay, if I change the equation, this is going to be my delta H is going to be plus 2877. Okay, for the conversion. And then you look at this 4 carbon. Okay, the carbon is still on my left. Okay, so 4 carbon. So it must be 4 carbon means 4 times negative 394. I'm not going to write. Okay, carbon is settled. This one is settled. Hydrogen. Hydrogen is on my left. Hydrogen on my left also, but needs to times by 5. Okay, so 5 times negative 286. Okay, so now I'm confident, no need to write. I know when I add this, it will give me the answer. So the answer is going to be 2877 plus 4 times negative 394 plus 5 times negative 286. So you calculate.
Negative 129.
Yeah. So you get this. Okay, you can continue to calculate. Yeah, but let's actually move on. Yeah. So question number 11. Okay, hydrogen peroxide slowly decomposes. Yeah, the enthalpy change of reaction can be calculated using the following information. This one is here. You want to calculate something, but they give you formation. So Wilson, which method do you prefer? They give you formation, many formations. try to avoid method number 1, method 2, Mr. Gopi, method 3, rearranging. So which one do you prefer most of the time, Wilson? Rearranging again.
Yeah.
Okay, if you prefer that method, you stick to that. Yeah, but for this one, okay, the best method is going to be my method is quite fast. Yeah. So you see here, okay, they have given you the formation of hydrogen peroxide. 2 times of this. Okay. To form oxygen is 0. You need to form oxygen. To form water, formation 2 times negative 285.8. Okay. So you want to find this delta. So you clockwise equals to anti-clockwise, negative 187.8 times 2 plus enthalpy change of the reaction equals to 2 times 285 negative 285.8 plus 0. So this one will be plus 187.8 times 2. And you will get the answer. Okay. So Wilson, if you still doing the rearranging the equation, most probably you're still writing the equation. Yeah. So just learn, just learn different methods where you can apply as long you can calculate, because in the end, okay, paper 1 is basically time methods. So you need to know which one to use, okay, in order to get the marks and answer quickly. Yeah. So what's the answer, guys? Aurelian, Mayumi,
Oh, wait, sir.
Mayumi, is everything all right?
Yeah, just now you were just lagging a lot.
Oh, I'm lagging, yeah.
I don't know, like the audio quality was really bad also just now.
Okay, okay. But Aurelia and Wilson, am I lagging? I think my internet connection is okay.
No, sir.
No.
196. Yeah. I got
196,
positive 196.
I also got 196.
Negative, yeah?
Yeah, negative 196.
Yeah, it should be negative value.
Okay.
Check again, yeah? I think roughly negative 400. I don't think so. You check again. 300, 300, 600, 600. You might plus with 400. Yeah, I think you will get around negative 196. Okay, Wilson, just confirm this. Okay, whether you get negative 196.
Yeah, I got that too.
Okay, so let's move on, yeah? Okay, question number 12. So the first stage, okay, of this production, the following equation, use the following standard enthalpy change of formation, yeah? So many formation are given, okay? So many formation given, yeah? So Wilson, please take note. If many formation is given, the best method to use my method, yeah? So Wilson, please take note. So it will be saving a lot of your time, okay? So here, okay, the formation, okay, so this will be 4 times negative 46.1. To form oxygen, 0. To form NO, 4 times 90.3. To form water, okay, so it's going to be 6 times negative 241.8. Put a circle there, okay, so you have, okay, 4 times negative 46.1 plus 0 plus delta HR, okay, equals to 4 times 90.3 plus 6 times negative 241.8. Take everything. And then you plus
negative 905.2 ya.
Yeah, the others also, yeah. So maybe we'll wait for another 1 more percent.
Oh iya.
Okay, once you calculate according to my working, yeah, you should actually get the correct answer.
Yeah, same, sir.
Okay, so this is the. So for today, we try to finish up to question number 13. Yeah, today is the this is the last question. Yeah, actually, I wanted to make it longer, but again, I promised my kids to bring them to watch movie. So another one we can do it in class or maybe any of the days extra class after school or what. Okay, but I will do it through Zoom. Yeah. So we will get it done. So this question number 13. Yeah, our last question. Titanium occurs naturally, whatever, blah, blah, blah. Okay, the enthalpy change of formation, many formation is given. What is this? So again, you see, yeah, many formation is given. Okay, so use my method, yeah. So up to you which method you want to use. Okay, but again, I feel this method will be faster. Yeah. So to form formation, yeah, they already gave. So this is negative 940. To form this, okay, you don't need to form element, so it's 0. Okay. To form titanium, okay, is already element 0. Okay. To form this 2 moles, so 2 times, okay, negative 110. Okay, so you put this circle there. Okay, clockwise equals to anti-clockwise. 940 plus 0 plus this equals to 0 plus 2 times negative 110. So this is 220 plus 940. Answer will be positive something. So Wilson, did you get the answer?
Yes.
Okay, so I think that's it. Okay, from me. Okay, for this, but actually, I wanted to also go through this one. Yeah. This is example. Okay, of paper 2 question. Yeah. So I have only 2 questions. Okay. Are you guys rushing? But I think I'm rushing. Yeah. But maybe I'll just show you one. Yeah. I'll just show you this. Yeah. So here they have this many formations. Yeah, so I'll just show you because it's we just now we do a lot of paper 1 questions. Yeah, but now this is paper 2. Okay, and they have given you many formations. Okay, many formations, and you are going to calculate this value. So this one, Wilson, I'll ask you which method do you think it might be easier to do this?
Your method, the
Yes,
GOPI.
yeah. So this is going to be the best method is to use my method. But again, this is paper 2. Yeah, you don't want to show them all the unnecessary work. Yeah. So you just show it. Okay, this is the formation. Yeah, so you just put the value negative 287. And then this one is also the formation. So you just put negative 320.5. And this is going to be formation also. I just put negative 414.5. And this is also a formation, but this one 2 times, okay, negative 281. So the one that I will show for my working is, is the clockwise equal to clockwise. So this one is important. So you write down negative, must write down, yeah, don't skip this, yeah. So this one plus, okay, negative 320.5 plus enthalpy change of the reaction, this one, yeah. And then must be equal to negative 414.5 plus 2 times negative 81. Okay, and then you calculate the enthalpy change of the reaction. Okay. This is how you can show my method, but no need to make it so obvious that you're using a separate method. Yeah. So once you do this, automatically, okay, once you get the answer, okay, kilojoule per mole, okay, make sure you put it positive or negative. Yeah. And then you just write down, yeah, is it 2 marks? So you write down, okay, for 2 marks, okay, you need to make sure that you have the plus or minus and then the correct value. Okay, so once you get that, yeah, the 2 marks is for you already. Yeah. And then this is simple calculation, question number 1. Yeah. And then you can see some questions, they will ask you about the definition. Yeah, what is meant by here they say what is meant by standard enthalpy change of formation. Explain what is meant by standard. So they are asking you the definition of formation. At the same time, they want you to write down what is standard. Okay. So maybe Aurelia, what is standard change, enthalpy change of formation? Are you there? Wilson?
Enthalpy change when one
1 mole of a substance am I laggy over here?
yeah.
Yeah. So maybe it's supposed to be, yeah, 1 mole of substance. Okay. 1 mole of substance is formed from, okay, 1 mole of substance is formed from its elements in standard state. Okay. So standard means, okay, 25 degrees Celsius and 1 atmospheric pressure. Okay. Wilson, can you still hear me?
Yes.
So you need to mention about 2 things. Okay, this and this. Okay, write an equation with the state symbol formation of water. Yeah. Water is H2O, must be liquid state. H2 plus O2, H2 must be gas, O2 must be gas. So you have 1 mole over here. So this one must be. Okay, if you have different value than this or different answer than this, your answer will be wrong. Yeah, please take note of that. Okay, explain why, okay, enthalpy of formation of water is identical to the standard enthalpy change of combustion of hydrogen. Okay, because they have because 1 mole of H2 reacts with excess oxygen, okay, based on the equation of enthalpy change of formation of water. Okay. So all these will give you same, basically you see, you need to mention 1 mole of H2, yeah, because combustion is 1 mole is being burned with excess oxygen. So I'm actually just connecting to that, yeah. So that is going to be the one that will give you the mark, okay. And let's say here, okay, when calcium, okay, placed in water, okay, hydrogen is given also. Calcium, okay, you react with water, okay, give you calcium hydroxide. Then, okay, this one is the one that I told everyone that I'm skipping this part for now. Okay? But I think in the class I will go through this. Yeah. So this one is going to be okay. I don't mind teaching now also, but in the class I will teach again. Now, when you have, okay, when you, let's say, water, then you put 1 gram of calcium, 1 gram of calcium, we can actually, the temperature increases. Whatever, let's say, for example, a particular reaction, in this case, calcium is reacting with water. Yeah? And they are giving you, basically here, I haven't balanced the equation yet. Yeah. So hydro oxygen, there's two. So, yeah, now it's balanced. Okay. Now, basically, calcium is reacting with 2 moles of water, okay, to give you calcium hydroxide and hydrogen. And this reaction, you can see the temperature is increasing. So, Mayumi, is this endothermic reaction or exothermic reaction? Oh, really? Maybe you can help.
EXO.
Yeah, it is exo reaction, yeah, exothermic, because temperature is increasing, so heat is given out. So when this reaction is actually heat is given out, yeah, do remember, okay, this heat, okay, is going to be absorbed by the water around. Yeah, it is going to be absorbed by the water around because when I place the thermometer in the water, yeah, into the water. I don't place it into calcium. I want you to understand this. Yeah, when I place it into the water, it means that all the heat energy that is going out, we assume the heat energy is absorbed by the water. This is very important. Yeah. Now, it means that, okay, when we use the formula, okay, we will use the mass of water, not mass of calcium. Why? Because we are calculating or assuming, okay, we are going to use, okay, this water, okay, let's say for example, whatever energy that is given, it went from the calcium to water. In the formula, we are going to use full water. Okay, we are going to calculate because the temperature change is for the water. Okay, once I get that, then I will recalculate to come back to calcium. This is very important because students will get confused in this. Why we have the mass, okay, calcium, we have the mass of water. Why in the end we still use the mass of water only? Why not both of them? The answer is because we are assuming everything into water. We calculate for water, then later only we calculate. In this case, yeah, when we want to calculate the heat release in this experiment, okay, the formula is Q M C delta T. The mass that I am going to use is not the mass of the calcium. This okay, 200. Okay, I'm going to use 200. Why? Because the heat capacity is in gram, yeah, joule per gram. So the C is the heat capacity, which is going to be 4.2. Okay, be careful with this because in physics, maybe you are going to use kilogram. Okay, and then the C we use 4,200. Okay, so for chemistry, please be careful. Yeah? We are using gram. Okay? And then the C we are going to use the 4.2. Delta T is the change in temperature. Okay, it doesn't matter. They say increase by. Let it be increased by 1 Celsius or Kelvin, even though temperature we count using Kelvin. The difference between, let's say, for example, 80 to become 100, okay, it is 20, okay, plus 20 degrees Celsius. But if you have, let's say, in Kelvin, for example, Kelvin is going to be 373. This one is 273 plus 80. So you have 353. If you calculate this is also plus 20. It's still the same. Yeah, so you no need to convert. Don't go and add 12.2 plus 273. Very important. You just use 12.2 because it's a change in temperature. Okay. And then, okay, you get this value. Supposed to be this is negative because release. Yeah. They say heat release means it's understood it's negative. Yeah. So you do not need to rewrite, okay, the answer in negative. Okay. You just, it's okay to give the answer in positive value because they already say heat. So you calculate this and you will get the Q value. Okay, the Q value is going to be joule. Yeah. Okay, so that is going to be the value. Okay, for the heat release. Can you guys calculate this quickly for me?
One oh two four eight.
102.8. Am I correct?
1024848, sir.
Okay, together, yeah. So no decimal. So this one, is this correct, Wilson? 10248.
Yeah.
Okay, so you can change it into kilojoule if you want. Yes, so 10.2. If you want to change it to kilojoule, you change it into 3 decimal places. Yeah. But if you want to show the entire one, you show all the 5. Yeah, so this one is going to be, this is okay, kilojoule. Okay, but do remember heat is released here. When you do the enthalpy change calculation, please remember it is negative, yeah, negative 10.2 kilojoule. You changed it into kilojoule, yeah, because they want in kilojoule, yeah. So just now we calculated in joule, yeah. So 10.2 kilojoule. Now they say calculate. It means that, okay, please remember this is 200 gram and this was 1 gram. Okay. So it means that the amount of energy that you get over here must be the same as for the 1 gram of calcium. So this is going to be this amount of the energy is for 1 gram of calcium. Okay, please remember that. So standard enthalpy change of reaction for your equation in B1. So you want this, yeah. So V1 for 1 mole. Okay, V1 for 1 mole. Okay, so you need to recalculate this for 1 mole because this is for 1 gram. So calcium, you need to go and refer to your periodic table. Okay, can someone help me with the periodic table? What is going to be the NR for relative atomic mass for calcium? Is it 40? Can you check?
40.
Yeah, 40. So first of all, okay, find the number of moles of 1 gram of calcium. Yes, so 1 divided by 40. Okay, this is the number of moles. Okay, number of moles. Okay, so 1 over 40. Okay, mole. Okay, gives you negative 10.2 kilojoule. I want for 1 mole. So therefore, negative 10.2 kilojoule, you times by 40, you will get negative 1. Okay, that is your value. .408, yeah. So 408 kilojoule per. Okay, that is the answer. It means for 1 mole, it will release this amount energy. If you don't have negative over here, no marks will be given, yeah. Please remember, okay, that's why it's very important. Why no negative over here? Because they say release still okay. But enthalpy change must show that it's exothermic. Okay, so Wilson, okay, all this?
Yeah.
Okay, so we are almost going to finish already. Okay, so state HESS'S law, Aurelia. I started the worksheet with HESS'S law, but you joined a little bit late just now. So HESS'S law, what is the definition, Aurelia?
Total energy change of a reaction is independent of the roots taken.
Yeah. Total energy change of a reaction is independent of the. Okay. Now, use HESS'S law, okay, and your results in B3 to calculate enthalpy change of formation. Okay, you also need enthalpy change of formation of this. Okay, so you want to calculate enthalpy change of formation of this. So let's actually do it like this. Okay, to form this, you need calcium, oxygen, you need hydrogen. And then, okay, oxygen is balanced, hydrogen is balanced, calcium is balanced, okay. So you have calculated enthalpy change of reaction, which is this reaction, okay. So I have, okay, you want to calculate this, okay, I think this one, hold on first, okay, I will take this reaction first. Copy, I put here. And this value we have calculated just now, and the change of reaction is negative 408. So just negative 408. So they want to calculate enthalpy change of formation, but they give you many like they have given you the formation of water. Okay, they have given you the formation of water. Okay, so I want the formation of this, yeah. So Wilson, okay, maybe this one need to think a little bit. So Wilson, which method do you think would be better to use for this?
Your method again?
My method again, yeah. So you see, they want the enthalpy of formation. So this one I want to find. Yeah, I want to find. So formation of water they have given. So negative 286. Okay, you times 2. You do not need this. So calcium is 0. Hydrogen gas, hydrogen gas is 0. So you just clockwise equals to anti-clockwise. So 0 plus and negative 286.2 times 2 times 2 plus 10 negative 0.8 equals to and enthalpy change of formation and plus 0. Formation of what? Calcium hydroxide. So I want to find the enthalpy change of formation. Okay, so the answer will be negative 286 times 2 minus 408. Okay, you calculate and you will get the answer. Make sure, okay, you change into kilojoule, yeah, because most of the time the student don't change it into kilojoule after they calculate this one. Okay, so it's very important to change into kilojoule. And make sure it's negative. If they don't get this negative, yeah, they might lose 1 mark in somewhere here because you will get a different mark or a different answer here. So what's the value? Negative what?
Negative 972, sir.
90.
972.
You need to add, yeah, correct. Okay. So 972, yeah.
Yeah.
Okay. So that's the value. Yeah. So then the last one, okay, they ask you to calculate the volume of hydrogen, okay, at room temperature and pressure. So do remember at room temperature and pressure, 1 mole, okay, is occupy 20 gas. Okay, 1 mole of any gas, okay, they will occupy 24 dm cube. So let's see how many moles. Okay, in this case, just now we calculated. This is 1 over 40, yeah. Okay, 1 over 40. So if this is 1 over 40 moles, okay. So how many mole over here? You see, 1 mole will give you 1 mole. So this is also 40 moles also. Yeah. So 1 over 40 moles of oxygen. So if 1 over 40, it means it's 24 divided by 4. Okay. Or this one times confused. 1 times 40, you get 1 over 40. So this one also times 1 over. So you will get 24 divided by 40. And the answer cube. You can leave your answer in dm cube, or you want to times Okay, you want to change it into meter cube, up to you. But normally, if they don't give your answer in fractions here. Not accepted in chemistry. 3/1. Okay, that's going to be 6 out of 10, so which is going to be 0.6.
Sir,
Yeah.
sorry. Just now the question before, the answer is negative 980. I input wrong.
Okay. Negative 980, yeah. Wilson, are you getting negative 980?
Yeah.
Okay. So anyways, okay, this one is the last one also we have calculated 0.6 TM cube. Okay, you want to change it into CM cube, you want to change it into meter cube. Again, all this conversion, okay, you figure out, yeah. So 1 dm cube, okay, is 1000 cm cube. So if you want to change it into cm cube, you times by 1000. So that's going to be 600 cm cube. Okay. But if you want to change it to meter cube, okay, because normally meter cube we change sometimes PV equals to NRT and so on. Do remember how to use that, because 0.6 times, okay, 0.6 dm times dm times dm. D is 10 negative 1, okay, 10 negative 1, 10 negative 1. So it's total 10 negative 3 meter cube. So you want to change, okay, so this one is 6 times 10 negative 4 meter cube. If you want to change it to meter cube, yeah, please take note. Okay, but leave it here. Okay, this is the best. Okay. That's all from me, guys. Okay. Any other questions that you want to ask? Mayumi?